Prove that sigma of n into sigma of n plus f equals to root pi into 2 to the power of 2n minus 1 into gamma of 2n. We already proved in the last class uh, from sigma of integration sigma to pi by 2 sine to the power of 2p minus 1 theta into cos to the power of 2q minus theta into d theta is equals to gamma of p into gamma of q by 2 into gamma of p plus q. Let it be 1. In this integration, put n is equals to p is equals to n, p is equals to small n, and q is equals to 1 by 2. In this result 1, we get what we get? We get integration 0 to pi by 2, p is n, so this is sine 2n minus 1 theta into cos 2 into 1 by 2 is 1 cos to the power of 0 theta into d theta is equals to gamma of p, gamma of n into gamma of 1 by 2 by 2 into gamma of n plus half. Okay, now put p is equals to n and q is equal to n. Now put p is equals to n and q is equals to n in 1. Then we get integration 0 to pi by 2, sine to the power of 2n minus 1 theta cos to the power of 2n minus 1 theta d theta is equals to gamma n by 2 into gamma n plus n, or this is equals to gamma n is equal to gamma n whole square by 2 into gamma of n plus n is 2n. Gamma of n plus n is equals to n. So now I want to simplify cos to the power of this implies that integration 0 to pi by 2, 0 to pi by 2 sine 2 theta is equal to sine theta cos theta. So 1 by 2 to the power of 2n minus 1 into 2 cos theta sine theta power 2n minus 1 d theta equals to gamma n whole square by 2 into gamma of 2n. The constant value comes out. This implies that 1 by 2 to the power of 2n minus 1 into integration 0 to pi by 2 sine theta cos theta sine 2 theta sine 2 to the 2n minus 1 2 theta sine to the power of 2n minus 1 2 theta, or sine 2 theta power 2n minus 1 d theta is equals to gamma n whole square by 2 into gamma of 2n. Let 2 theta is equals to alpha. Now let 2 theta is equals to alpha. This implies that 2 d theta is equals to d alpha. Now the limits also, when theta is equals to 0, when theta is equals to 0, this implies that alpha is equals to 2 into 0 is equals to 0. This is lower limit. And theta is equals to pi by 2. This implies that alpha is equals to 2, theta 2 into pi by 2 is equals to pi. This is upper limit. Now the integration becomes 1 by 2 to the power of 2n minus 1, 1 by 2 to the power of 2n minus 1 into integration 0 to pi, okay, sine alpha, sine 2n minus 1 into alpha is the end, and since theta d 2d theta is equals to d alpha, therefore d theta is equal to d alpha by 2. D alpha by 2 is equals to gamma n whole square by 2 into gamma of 2n, gamma of 2n. But it is same as 1 by gamma of sine to the power of 2n minus 1 d theta. I would like to change this integration as 2 to the power of 2n minus 1 into integration 0 to pi sine to the power of 2n minus 1 d theta by 2 into 2, so 2 to the power of 2n, 2 to the power of 2n is equals to, or 2n minus 1, sorry, 2n minus 1 by 2 is equals to gamma of n whole square by 2 into gamma of 2n. But when we put the value p is equals to n and q is equals to 1 by 2 in 1, then we get integration 0 to pi sine for 2n minus 1 theta is equals to gamma n, gamma of 1 into 2 gamma n plus f. So I will substitute this value. Therefore this implies that 1 by 2 to the power of 2n minus 1 into 1 by 2 in the integration 0 to pi, 0 to pi, integration 0 to pi sine to the power of 2n minus 1 theta d theta, or I would like to cancel, okay, cancel these things. Theta is equal to gamma of n whole square by 2 into gamma of 2n. So this implies that 1 by 2 to the power of 2n minus 1 into 2 times integration 0 to pi by 2 sine to the power of 2n minus 1 theta d theta. Since sine theta is an even function, so integration 2 into integration 0 to pi by 2 d theta is equals to gamma of n whole square by gamma of 2n. So this implies that 1 by 2 to the power of 2n minus 1 into 2 integration 0 to pi by 2 sine 2n minus theta d theta equals to gamma n into gamma of by 2 into 2 into gamma of n plus f is equals to gamma n whole square by gamma of 2n. So 2 get cancel. Gamma n times cancel. So this implies that gamma 1 by 2 to the power of 2n minus 1, gamma of is root pi, and gamma of 2n equals to gamma of n into gamma of n plus half, gamma of n plus f, or gamma n into gamma of n plus f equals to root pi by 2 to the power of 2n minus 1 into gamma of 2n. So it is what we have to require to prove. Gamma of n into gamma of n plus half is equals to root pi by 2 to the power of 2n minus 1 into gamma of 2n. So gamma of n into gamma of n plus half is equals to root pi by 2 to the power of 2n minus 1 into gamma of n. సో ఇక్కడ ఒక రిజల్ట్ ఎక్స్ప్లెయిన్ చేయాలి. గామా ఆఫ్ 1 by n, గామా ఆఫ్ 2 by n, gamma of 3 by n, and so forth. Gamma of n minus 1 by n is equals to 2 pi power n minus 1 by 2 by root n. So here I don't want to explain this result, but based on this result I want to do some problems. And now take the problem. Gamma of 1 by 9, gamma of 2 by 9, and so forth, gamma of 8 by 9. So observe this problem comparing with this result. Here n is equals to comparing with gamma of 1 by n, gamma of 2 by n, and so forth, gamma of n minus 1 by n. Here value of n is equals to 9. So LHS is equal to RHS, then RHS value is gamma of 1 by 9 and gamma of 2 by 9, and so forth, gamma of 9 minus 1 by 9, n minus 1 by 9, n. So this value is equals to 2 pi power n value is 9 minus 1 by 2, 9 minus 1 by 2 by root 9. So this equals 2 pi power n minus 1 is 8 by 2 is 4, by root 9 is 3, 2 pi to the power of 4, 2 pi to the power of 4 by root 9 is 3. Or this can be written as 16 pi to the power of 4 by 3. Second problem. Gamma of dot 1, gamma of 0.2, and gamma of 0.3, and so forth, gamma of 0.9. This can be written as gamma of 1 by 10, gamma of 2 by 10, gamma of 3 by 10, and so on and so forth, gamma of 9 by 10. So this is equals to gamma of 1 by 10, gamma of 2 by 10, and so on and so forth. Gamma of 9 is 10 minus 1 by 10, gamma of n minus 1 by n formula. So this is equals to 2 pi to the power of n minus 1. N is 10, 10 minus 1 is 5 by 2, 5 by 2 by root n, root 10. So 2 pi to the power of 10 minus 1 pi to 10 minus, sorry, 10 minus 1 is 10 minus 1 is 9, 9 by 2. 10 minus 1, 9 by 2 by root 10. Next. Prove that integration 0 to infinity e to the power of minus ax into x to the power of n minus 1 into cos bx into dx. It is the complex oriented concept. It is complex oriented concept. So one thing you should need to draw. So when I write e power I theta means when I write it, when I write e power I theta value is cos theta plus I sin theta. Similarly, e power minus I theta value is cos theta minus I sin theta. And in a complex number, if alpha plus I beta is a complex number, is a complex number, then alpha is called as real part of this complex number, and beta is called as complex part or imaginary part, imaginary part of that given complex number. So when a complex number is given a number without I is called as, the part without I is called as real part, and with I is called as imaginary part. So in e power I theta is expansion cos theta plus sin theta, and e power minus I theta value is cos theta minus I sin theta. So now consider to prove this result, we need to consider integration 0 to infinity e power minus ax and e power I into bx into x to the power of n minus 1 into dx. So e power minus ax plus e power, so this can be written as integral 0 to infinity e power minus a plus ib times x. I need to take minus as common. E power minus a minus ib into x, minus a minus ib into x to the power of n minus 1 into dx. Here you need to remember the formula that e power minus kx into x to the power of n minus 1 is gamma of n by k to the power of n, gamma of n by k to the power of m. So here the formula based on integration 0 to infinity e power minus kx into x to the power of n minus 1 into dx is equals to gamma of n by n to the power of k, okay. This is the known formula. So now this value is equals to value is equals to integration 0 to infinity. This value is gamma of n. Gamma of n is gamma of n by n to the power of k. K value is a minus ib. N to the power of a minus ib. So k to the power of n. So n to the power of k. So for the formula is k to the power of n. K to the power of. So this is equals to gamma of n. N is gamma of n, and k value is a minus ib. A minus ib power n. So now I would like to, this value is equals to, this value is equals to gamma of n into a plus ib to the power of n by a minus ib to the power of n into a plus ib to the power of n. So this is equals to gamma of n by a plus ib into a minus b. B is equal to a square plus b square. So a square plus b square power n into a plus ib to the power of n. A plus ib to the power of to the power of n. So put a is equal to r cos theta. Put a is equals to r cos theta and b is equals to r sin theta. This implies that a square plus b square is equals to r square cos square theta plus r square sin square theta is equals to r square. Now the result is integration 0 to infinity e power minus e power minus ax into e power ibx into x to the power of n minus 1 into dx is equals to gamma of n by a square plus b square into a plus ib to the power of n. A plus ib to the power of n. Now a is equals to r, this is equals to gamma of n by a square plus b square is equal to r square. A square plus b square whole to the power of n is r square and r to the power of 2n into a is equals to r cos theta plus I into r sin theta whole to the power of n. So this is equals to gamma of n by r to the power of 2n minus 1 into cos theta plus I into gamma of n by r to the power of 2n minus 1 into applying de Moivre theorem. This is cos n theta and this is equals to sin n theta. Sin n theta. Now comparing the imaginary parts and complex parts. So this implies that integration 0 to infinity e power minus ax into e power ibx means cos bx plus I sin bx, cos bx plus I sin bx into d into x to the power of n minus 1 into dx is equals to gamma of n So this is equals to gamma of n and r to the power of n into cos theta plus I sin theta whole to the power of n by r to the power of 2n. So this equals to gamma of n by r to the power of n, 2n minus n is n. And now I apply De Moivre's theorem. That value is equals to cos n theta plus I sin n theta. Now I would like to divide this into two parts, that is in as parts of real and complex parts. So gamma of n by r to the power of n into cos n theta, this is real part, and I into gamma of n by r to the power of n into sin n theta, this is the imaginary part. So in this integration, in the above integration, integration 0 to infinity to e power minus ax e power I into x to the power of n minus 1 into e power I bx is equals to cos bx plus I sin bx into dx is equals to gamma of n by r to the power of n cos n theta plus I into gamma of n by r to the power of n into sin n theta. Now I compare the real and imaginary part. In this real, in the above, the real part is so integration 0 to infinity to e power minus ax into cos bx into x to the power n minus 1 into dx is equals to gamma of n by r to the power of n into cos n theta. Similarly, when we comparing the imaginary part, the integration 0 to infinity to e power minus ax into sin bx into x to the power of n minus 1 into dx is equals to gamma of n by r to the power of n into sin n theta. Thank you.